Okay, now we will be talking about linear momentum and angular momentum. So, linear momentum is, momentum is the tendency of objects to not change velocity, essentially, without applying some sort of force or adding or extracting energy from the system somehow. So this is given a mathematical representation through the value of linear momentum. P is equal to mv. So the linear momentum P is equal to the mass times the velocity. So in order to find the linear momentum, we take the mass of the object, we multiply it by the velocity of that object, and once you have that momentum, as long as energy isn't added or extracted from the system in some way, that momentum must be conserved, and that's how an object's tendency to not change velocity is mathematically represented. So for instance, I use this as the example. So if we have a particle of a mass of 2 kilograms, which is moving in the xy plane at a constant speed of 0.8 meters per second in the positive x direction along the line y equals 4 meters. As the particle travels from x equals -3, well, first let's talk about the linear momentum. So the linear momentum of this particle is pretty simple. It's going to be its mass, 2 kilograms, times its speed, or velocity, 0.8 meters per second. So if you multiply 2 times 0.8, you get 1.6. You get 1.6, and the units for linear momentum are kilograms meters per second, so we have a linear momentum of 1.6 kilograms meters per second squared. No, not squared, sorry. Kilograms meters per second. All right, so angular momentum is kind of like just sort of like the angular component of linear momentum. It's like, I guess, an object's tendency to not angularly accelerate. So that can also mathematically be represented, and it does relate to linear momentum. So angular momentum is defined as the radius cross linear momentum. So in this situation, we have 1.6 kilograms meters per second of our linear momentum times a radius of 4, and that radius of 4 comes from the fact that the particle is traveling along the line y equals 4 meters, and it's with respect to the origin. So the radius is 4 meters. Yeah, the radius is 4 meters because with respect to the origin, that's how far away yeah. Yeah, okay. That's how far away it is in the y direction. Right. So since we have that, we have r and we have the linear momentum, which we just solved for. We can use that. So linear momentum, angular momentum is equal to r cross p. So we have 1.6 kilograms meters per second for our linear momentum times 4 meters for our y direction radius, and that gives us 6.4 kilograms meters squared per second.